Give people a minute. Yeah, we're first session, so. Kick us off while you get that going. Yeah. All right. All right, everybody. Good morning and welcome to Bangkok. This is WIMSE. If you're not here for WIMSE, you're in the wrong room. For everybody here, please make sure that you log into the on-site tool. This is how we take attendance. And this is how the IETF knows how big of a room we need when we meet in person. So this is only Tuesday, only the first meeting on Tuesday. Please note the note well. And this is basically describing all of the IPR protections and everything about anything that you say here is considered a contribution. And you promise not to sue anybody over it or take out patents on something that somebody said and stuff like that. The actual legal stuff is in the links in the slides if you are so inclined. Like I said, everybody that's here, please sign in using MeetEcho. Use the on-site tool, not the full tool if you're here in the room. Everybody that's remote, please use the remote tool, not the on-site tool because you're not on-site. For everybody, especially those in the room, please use the mics, please use the queue. We do have remote participants. We do want to make sure that everybody that's attending remote has the full experience. And for everybody remote, please keep your audio and video off unless you are actively presenting or talking or asking a question. If I see somebody that's just kind of hanging out with their mic or camera on, I will just keep turning it off on you. I've already done that to somebody a couple times this morning. Let's not do that again. It's easy. It's really easy to misclick in the tool, but just do try to keep it off. Let's see. Yeah, you want to?
Good morning, everybody. I'm Peter Castleman, co-chair for WIMSE, and
oh yeah, and I'm Justin.
Yeah, this is Justin for anybody who doesn't know Justin. So welcome to WIMSE. A couple of agenda, or as they're better known these days, OKRs for this meeting. So we're going to stick to the time requirements fairly strictly, and so that'll be. So please stick to the allocated times. Quickly running through it. Looking forward to the architecture update, the new workload to workload, also identity best practices, some new proposals for credential exchange. And then a couple of new sort of topics that may or may not be related to workload identity or to WIMSE specifically. So we'll learn more about those later today. So today, interestingly enough, in fact, this time slot is exactly 365 days since WIMSE met for the first time. So thank you to the IETF for such precise and particular scheduling. I also want to take a moment to thank everybody who has come up to a mic, read a draft, created a draft, opened a PR, or commented on the mailing list for helping us make the progress that we've made in the year since we started. So thank you so much, everybody, for all that work. Without you, this would not have been possible.
Yes, and I do know of working groups that have lasted less time and also got done less than we have in 1 year, in taking many more years in doing so. So good job, everyone. Also, a particular, oh, Murray, go ahead. Yes.
Really quickly, this is my final meeting as your area director, so I wanted to say congrats on a good first year. Ori will be taking over for me. Sorry, Andy Newton will be taking over for me after tomorrow. So if you need anything, ask me today or tomorrow.
Awesome. Thank you, Murray. Also, a milestone for WIMSE is that in dealing with the working group over the last years has led to the inspiration of no less than 3 Cards Against Identity cards. For those of you that don't know, this is a game that I publish a new edition of each year, and all 3 of these are based on direct experiences from here in the WIMSE working group and around the IETF. So I've been told by some people that if you show up in Cards Against Identity, that means you've really made it. We got a lot of resources for the working group, the mailing list, obviously, our GitHub organization, and of course, our fantastic website that has all of the information linked on it. And it's a lovely website. We have 3 active documents. All of them have had revisions. I do want to note the middle one, the Workload Identity Practices, that went through a draft rename because it actually wasn't a BCP, so we had to get BCP out of the URL. The others have gone through several revisions. So that's an 01, but it's kind of an 04-ish. But the others have also gone through revisions since last we met, and we'll be hearing updates about all of these today. There's all sorts of discussions happening in WIMSE. As we go through, we will be asking who is reading the drafts, who's following the GitHub discussions, but there's also additional conversations that are relevant to WIMSE that are happening elsewhere, namely transaction tokens and identity chaining, both in the OAuth working group, but also, and I didn't have a chance to update this on the slides, there's other stuff like the bot authentication that might be coming to the HTTP working group, and other related stuff that's kind of happening in this space. A lot of very interesting stuff that WIMSE is really kind of hitting in a lot of different ways. And with that, yeah, I'll queue up the next slides if you want to say anything.
While Justin is getting up the next slides, our GitHub repository is where you can find all the documents. If you've read the documents, please feel free to open issues and help the authors and the editors make some progress. And next up, Joe is going to give us an update on the WIMSE architecture draft.
All right. Hello, everybody. Joe Salloway and my co-authors, Yaroslav and Hannes, have delegated the privilege to me to present to you an update for the WIMSE architecture draft. Which one is me? Can you tell? Obviously. All right. So we had an interim earlier this year on the WIMSE architecture spec, and basically we haven't done all that much since then. We'll go through some of the updates, but what we did at this point that I'll just recap really quick is we've added some scenarios that we think are important for workload identity, and I'll just click through here. So we have a basic scenario which kind of highlights workload to workload communication, and what we have here is a fairly typical deployment where there's a gateway. We'll talk that some of these names probably need to be updated. This gateway is kind of translating between the outer world and kind of the trust domain within this environment. And the workloads are communicating to perform some sort of task, and a credential or a CA service, a credential service, is issuing credentials for those workloads to be able to identify each other. This is kind of probably the most basic sort of scenario we could put together. The next starts talking about, well, actually there's some other information that in a workload environment that's typically being used to make authorization decisions or to record audit information. And that's this, what we call a context. And I think in the draft, we may call it a security context. And this is something that often a gateway service is responsible for taking some external information like an OAuth access token and translating that into maybe a transaction token that has information about the user and other attributes that have been derived that kind of is important for each of these workloads to kind of figure out what they're doing or how to authorize the transactions. And then finally, often we are not just communicating with our own little environment. We have to talk to external infrastructure that's maybe part of a cloud provider or part of a whole other service that is part of doing the processing that we have to do. And so this is kind of a cross-domain communication. So these are kind of the scenarios that we've outlined right now. We would love to hear if there are other scenarios and certainly refinements to these. This is, definitely a work in progress. And so really looking forward to people throwing out any additional ideas that they have. So between the interim and now, we've done some mostly we've closed a bunch of issues. We still have a bunch open, but, gotten through some of the editorial and terminology stuff, still have there. But, please keep posting issues to the GitHub repository. And, even PRs are welcome as well, so that we can continue to work through this document. So, there's some of the terminology changes we've made here is to clarify what a role of an identity proxy is, to be able to kind of add context into for the workload kind of at the gateway boundary. We've replaced identity with identifier because we all know identity is a word that is very difficult to define, whereas we're really talking in many cases right now about identifiers, and that goes specifically when we look at service-to-service authentication, we're looking at identifiers in that case. Certainly this fits in a larger context of identity, which is a much richer concept, but we're not trying to define that complete universe here. We've worked through some of the descriptions of the bootstrapping of how identifiers and credentials are acquired by the workload. I think how much this architecture document goes into that process is something that we have to probably have a discussion as a working group. I think it's a little bit maybe on the outside, but certainly is important. This is an important step in how we get the identity to the workloads. But there could be many different ways to do this. There exists many different ways today to do this. I don't know how much we need to go into that, but we certainly need to go into it enough to be able to differentiate at the level of, so if this impacts what the identity is or attributes of that identity, then we probably need to discuss some of that in our discussion. And then we, a little bit more clarifications on context. Yeah, and we introduced the term WIMSE token to encompass both X509 certificates and the JWT WIT tokens that we use in the service-to-service spec. And we define trust domain as kind of a refinement of the definition that was already there as a collection of workloads under the control of a single administrative authority. So we've done some work on remote attestation. It's synced some with the RATS working group, but I think we have a bit more to do in terms of the terminology there throughout the document isn't completely aligned, and we'll work with some folks, Usama and other folks, on trying to get that to a good point. And we talked a little bit more about when we're crossing the boundary between going outside of the environment, you may not be wanting to expose all the details of your identity that you use within your environment externally. And so there's this concept of identity generalization as you egress from your internal environment to some other, another domain. What information do you allow to go through, or you kind of maybe remove some of the specifics of that identity. Okay, now here's the interesting part, because what are we going to look to be doing next? Right now, we feel there's a lot of alignment of terminology that needs to happen, not just between the WIMSE documents. Okay, to kind of we have a number of different documents that have been progressing, together, but not all of the terminology is completely aligned. We'd like to get that. That should be possible to do, at least within our working group, what words we use. There's also aligning terminology with other groups in the IETF, very specifically OAuth. There's, I think Peter mentioned the cross identity or cross-domain identity work and transaction tokens. We should try to align where we can, or at least point to, it may not be possible to completely align the terminology, but at least point to what's similar and what's different about what the words other groups are using. And then there's aligning with other areas of the IETF and other areas in the industry. So that's a bit of work that we need to do. I think there's more work that needs to be done to talk about different types of authentication mechanisms and different things you might do with that authentication in terms of impersonation and delegation. These are things we kind of started to talk about in the document, but haven't gotten we don't have a scenario that specifically addresses those things. And we haven't really put a framework around that. I think there needs to be more work there. And the same thing with cross-boundary, cross-domain use cases. If you looked at the slides you earlier that I showed of cross-boundary, cross-domain scenario, it's a pretty simplistic view of things, and it probably needs to be more enhanced a bit to kind of align with what's happening in OAuth. Security, we have to do some work with terminology and authorization and authentication. Like to continue on with defining attestation a bit better. And I think we need to continue to work through what the threat model is that we're operating under, because that kind of will define, we'll have different options. I think even in, for example, in service-to-service authentication, you'll have different options that may work better or worse, or provide different security properties in different environments. And it would be good to help people be able to evaluate that against what threat model they might have.
Joe, there's a couple of questions in the queue. Do you want to wait to the end, or do you want to take them now?
We could take them now. That would be, yeah.
I think this is the last slide anyway.
Yeah, this is
the mic's in the middle.
This is it, and this is, we want some feedback on where we should be going with this. Yeah.
Hey Joe, thanks for the update. Dean Sachs. On the impersonation work, there was an active discussion at OAuth Security Workshop 2 weeks ago around delegation and on behalf of semantics. That work has been captured in the EKYC group at the OpenID Foundation. and there will be further work happening there around that topic. Might be something for you to follow, might be something for you to take a look at. Not sure exactly where that's going, but I just want to kind of bring those threads together for you
Cool.
because it may intersect with what you're trying to do here in WIMSE. It may not as well, but it might be something for you to take a look at.
Yeah, thanks. I think it definitely something we would want to take a look at.
Fantastic.
So I'll follow up and get some pointers. You're on.
You're on, Chef. I have 2 comments. I'll start with the more important one. I think WIMSE token is a really bad name to include certificates, and I suggest WIMSE artifact. And then to this slide, a while ago, well, probably before the working group was formed, we discussed large WIMSE deployments and basically hierarchical or distributed issuance of identities, where you may have a local agent that's only allowed to issue identities within some workspace or some section of the environment. So when we talk about cross-domain, we kind of leave the responsibility to someone else and only talk about the interface. But when we talk about scalability of WIMSE deployments, then the responsibility is more on us to say how this is defined. And I think it is worth consideration to start with at the architecture level.
So that you're saying scalability within the trust domain and how we do delegation and things like that within.
Yes.
Yeah, I agree that that's something because we've already seen discussions of this on the list in some areas, and I think it would help to put some more framing around it, because I think that's a good point. With regard to the name, WIMSE credential is might be good as well. We have WIMSE token on the slides. I'm not sure if that's the name we actually agreed on in the draft or not, but we'll figure that part out.
Yeah.
What
It's not in the doc.
WIMSE token?
It's not, yeah.
Yeah. So
Because there's not different, like,
yeah, we'll
all the
have to.
combos and all the different kind of
That's
other things. I was
Ignore
actually,
that
though,
part. I
particularly
think we
interested
went
in,
with credential
video
maybe.
delivery
But I agree.
VR
Token
and other
is
congestion controllers.
when I was.
I think you mentioned
anyway.
Dash, like some sort of Dash simulation at some point. I'd be fascinated to see more about that, since that's obviously a use case near and dear to my heart.
Yeah, we're getting somebody
maybe for
else's
another-
microphone bleeding into this room. I'm not sure what's up.
I think we're okay now.
I think we're good. Okay.
All right. That was
That was-
interesting.
Okay. So if
All right.
if the mics had widths, this would all be fine.
Yeah. Peter, did you?
Yeah, I was going to comment on the WIMSE token. I think there was an issue opened about that, and I do think you changed it to WIMSE credential. Another way to talk about it is similar maybe to how the SPIFFE community talks about these things as identity documents. Credential probably just works better for the audience.
Justin, speaking as chair, naming things is hard. We're not going to bike shed it here in this room, but it is important to get names right. Things like token and credential mean very specific things in specific communities. They carry baggage with them, whether you realize it or not. All of the names that have been brought up are bad in particular communities for specific reasons. And I could go into the details of why, but that's not a worthwhile use of our time right here. I do recommend that that the group actually do put some thought into this, because this is a very fundamental thing that we're talking about. It's a very fundamental building block to all of the different parts of WIMSE. So we should have a name that we can that is descriptive, that we can defend, and we can differentiate from other things in the community. Speaking as an individual, yeah, token is a really bad name for something like this. But there's a lot that goes into picking a good name.
And I think the only thing I have left here is describing identifier formats, and that's if, right now, WIMSE is identifier is a URL that starts, we don't even define a scheme for it. We just say it has to have a trust domain to begin in the beginning of the kind of the host name part of it. Do we need to do more here? Is it useful to do more, or should we just leave that for maybe some other document, or is it just a deployment specific thing? Is a kind of a question that I think we'll need to answer at some point. But I think that's all we have. This is it. So if anybody has any other questions, that'd be great. If not,
Samati Dresden. So can you please elaborate on the confidential computing? Are you saying that there is an open issue, or are you saying that until the next meeting you are planning to be consistent with the terminology in other domains?
I think we have to look into what we with there and where it makes sense. I personally don't have enough background in that area to be able to say exactly what we would need to do there, but it's something that we have had people ask about. And so I think we want to try to align where we can, at least with the terminology, so we can evaluate what we're doing against that.
So currently there is no open issue on this, right?
I don't think so.
Okay, right, thanks.
Okay, thank you.
All right. Thank you, everybody.
Yaroslav. Sorry.
It's right there. Oh, there it is.
Oh,
It's
okay.
behind the screen. Yeah.
All
go for
right.
it.
I thought about it.
All right. Good morning. I'm Yaron Sheffer, and with me on this amazing editor team is Joe that you've just heard. Brian was sitting behind there and planning to heckle me, and Arndt joining remotely. Next, please. No, that's me. And we're not service to service anymore, even though the draft's file name is still S2S. Just in order to confuse you guys, we are now workload to workload, and we actually made it consistent across the draft that we're talking about, workload to workload authentication authorization protocol. We published 2 versions of the draft since the last IETF, 02 and 03, with a long list of not huge issues, mostly. So this is more level, and I will be talking specifically about the 2 things that are in bold, so coexistence with bearer tokens, and some work that we've been doing with the SPIFFE community. But you can see that we made some work on, we did some work on the contents of the WIT, WIMSE identity token, and the WIMSE proof of possession token, the WIPIT. And some additional work at global scope across the document. So one of the core issues is the draft requires proof of possession to go with the identity token. It can be done. So the draft, as a quick reminder, supports 3 ways of authenticating workloads to one another. One is with MTLS, but I will not be discussing that. And the other two are application level, where the WIT is sent over the wire along with proof of possession, and the proof of possession takes either the form of a token, and that's the WPT, the WIPIT, or HTTP message signatures that implicitly provide proof of possession for the WIT. However, as we all know, most people are using bearer tokens and sending tokens back and forth. And so there's the question of how do we interoperate? Do we allow people to send WITs as those tokens? So that's an issue that we discussed. WITs are going into their own HTTP header that we're defining in this document. And they have their own constraints on which claims to use and so on, which makes them likely different than what you're using today anyway. So our position is that it simply doesn't make sense to use those WITs as bearer tokens. If you want to send bearer tokens along with your WIT, go ahead, send your legacy bearer tokens as well as the WIT, but don't try to cram both of them into one token. There's a new section on policies for migration from old bearer tokens into WIMSE, and also a discussion of the interaction with transaction tokens, which are another kind of bearer token. The issue is still open because of some detour we've had with SPIFFE, but I believe we have it now resolved. So if we don't hear any objections, we will be closing that issue. So speaking of SPIFFE, we went over to the SPIFFE community as one potential way of issuing WIMSE identities, WITs. They're happy to do that. They support our work. Some of the folks are actually in this room today. We got a review of the workload to workload document from them, with some minor issues discovered, but nothing major. So we have the SPIFFE stamp of approval, if you want, and a proposed API for issuing a new type of SPIFFE identity document to be known as WIT SVID. Since our draft is still a draft and still not stable, that will be, so on the SPIFFE side, that will still be a draft until we stabilize our stuff. But the expectation is to see implementations even before that. And so hopefully we will see running code. And the plan is that they should not be duplicating our document, but instead referring to it. One issue that came up and that I would like to bring up with this forum is trust bundles. Part of what you get when you connect to the SPIFFE API is a trust bundle or trust anchors. And this is something that we have not discussed here. And so SPIFFE itself is on the boundary of our scope. It's not really in scope for WIMSE, but this is, I think, on that same boundary, this is something that we may need to discuss here, whether we want to mention that you need trust bundles and how do you get them and stuff like that. And another point, we had a long discussion about the question, where do private keys, so WITs are bound to a private key. So where do these private keys come from? And right now the proposal is for them to be generated by the agent, which is typically on the same node, but is not on the workload. I personally don't like that, but I realize that this is the simpler way of doing it. So this is the current situation with the SPIFFE proposal. So SPIFFE work is ongoing, but it's more on the SPIFFE side than on our side. And lastly, and this is still open on the mailing list, and we're still soliciting a discussion on the audience claim. The audience claim is something that the sender puts into the whippet and does an equivalent for message signatures. But anyway, in the whippet, you put an audience claim, so the sender needs to know it, but the receiver needs to verify it. And then the question becomes, does the receiver really know what is being used as a request URI? Is there anything else that can be used that's known by both the sender and receiver, and so on and so forth? So we've been going a little bit in circles on this, and I don't know that we have a solution that's acceptable to everybody. Well, not even constraint, but the expectation is that there will be SDKs on both the sender and the receiver side, and they should be consistent, but they may allow for local knowledge to be inserted, like maybe converting WIMSE identity to a request URI, maybe vice versa. So this all goes into this same discussion. Yes, Rifat.
Sorry, my question on the previous slide, you mentioned trust bundles. Can you elaborate on this? What's the trust bundle and what's the role of those here?
Trust anchors, basically
Trust
what
anchors. Okay.
What's the your trust?
Okay. So I was wondering why you chose trust bundles instead of trust anchors.
SPIFFE terminology.
I see. Okay. Interesting.
Yeah, terminology is hard.
Okay.
Not that hard.
Let the notes show that Hannes believes terminology is not that hard. Don't waste our time.
Mr. Chofenig.
You kicked the ball over to me like in this case there's a clear term. It actually even fits. Trust anchor is like a well-established term in all sorts of different places, so it would have been useful to reuse it.
Yeah, but that's the fun with terminology. You can make your own.
If it adds value, yeah.
Well, from the SPIFFE perspective, just to be mindful, this is how that community refers to that artifact. And so to make this content accessible to them, right, it is useful to use some terminology that's familiar for the people who will be implementing this.
But you create confusion here, right?
Yes, but that we can clarify as well. So again, just for in terms of the origins, right, to an earlier point that Joe also made, mapping all these different terminologies across different groups is going to be an ongoing challenge for sure.
Yeah, and okay, we're not going to be discussing other communities' terminology. It's hard enough to do our own. And with that, there's quite, well, a few dozen issues remaining. This is, in fact, a picture from Madrid. Well, not mine, but this is Madrid, probably not in July, but still nice. Thank you.
Okay, any questions for your Ron?
All right, not seeing anybody in the queue. Thank you. I meant to ask this for each of the drafts, actually. Who has read the latest architecture draft? Hand up. Okay, so that's like the authors and one more person. Well, some of the authors and one more person. Okay, and who has read the workload to workload draft? More hands on that. Awesome, thank you. Cool, all right. I'm gonna queue up the next slides. Now it's your turn, I think. All right, the clicker should work.
Okay.
Yep.
Hello, everybody. I'm Yaroslav. On behalf of authors, I'd like to give you an update on workload identity practice draft. This draft, since IETF 1.2.1 changed its name, didn't change its nature. So it's still talking about current practices of using OAuth assertion flow to get access token and then use that access token for workload authentication. There is a consensus that's not the best practice, though it's a current practice or the current practice when it comes to OAuth, so hence the name change. Now, in addition to renaming, we actually added quite a bit of contents. So there is a new credential issuance section that walks through three common patterns of how a workload obtains its credentials. Could be container environment, could be virtual machine, could be something else. And then we've done a bunch of clarifications which are primarily security centric. So looking at things, how not to shoot yourself in the foot too badly. So again, as a reminder, this is the common pattern that we begin our conversation from. So typical OAuth assertion pattern where you have a workload obtaining somehow, and now we have three different methods explaining that somehow initial credentials issued by the platform, and then workload is using that to obtain access token from authorization server and using that to access the protected resource. This pattern is surprisingly common, so it's used in containers, it's used in virtual machines, and in some CI/CD infrastructure. In the appendix section of the draft, we include some specific examples of where this is used. Now, the new exciting stuff, or not so exciting, but new stuff in this draft. Credential issuance. One common pattern is environment variable. Obviously not super secure, but have its time and place. A very simple way to obtain credentials, just put it in environment variable and then use that. Kind of useful, especially for short-lived things like maybe Lambda functions or something where you don't really worry about long-term security aspects. Then we have files. Common example is Docker volumes or container volumes, where you deliver credentials as files that you attach to your container or to your virtual machine. Though the draft doesn't spell it out, cloud init in virtual machines kind of falls into the same pattern, though cloud init is quite messy, and so far we decided not to dive into the dark depths of that technology. And then last but not least, APIs. So SPIFFE and the likes, using local socket, could be Unix domain socket, could be something else, something that is specific. So after workload comes to life, it would use that local socket to get its identity and use it to then obtain access tokens depending on where it needs to go. Right, so there are a few questions that we have for the working group. Hopefully we will solicit some feedback. So far we described, again, very specific but common flow. So one of the questions is, there are a few other practices. Most of current practices are even more insecure, like basic authentication or using IP addresses as your credentials. Is it something that we should be mentioning in the draft? Like, don't do that, or just ignore this topic because we want to keep some level of sanity. Yeah, any additional suggestions on the security considerations would be very welcome. And then overall, the question is, what is the working group guidance on the next step? Should we be finalizing this work? We feel that we explored our current premises, our current flow and its applications quite sufficiently. In the current practices of workload identity, should we be looking for working group last call by the next IETF, or is the working group consensus that we're not quite ready and we need to get a few other things done? So with that, Mark.
Hi, can you hear me?
Loud and clear.
Great. So we're still figuring out how to deliver credentials to workload in the confidential computing environments. Certainly, we're not going to do it via an environment, because confidential computing doesn't trust the environment. Now, you don't need to do anything there other than leave it open for others to define their own methodology at this point.
Okay, I'm not sure. Was there a question there?
No, I'm just want to make sure that when you say, should other workload identity practices be described? Well, certainly confidential computing is going to be different from the main line of what happens right now. We're not going to be placing plain text credentials on volumes. Again, confidential computing doesn't trust its hosting environment, and there is remote attestation is involved, all sorts of things. So as far as the foundational document in WIMSE, I think the reasonable thing to do is simply leave it open for others to define their own mechanisms.
Oh yeah, absolutely. By the way, keep in mind, this is informational track document. It's not proposed standard or anything. Again, it's even not best current practice at the moment. So it's just describing very common OAuth-centric flow. If you believe that we should explicitly mention this is not about confidential computing in the document, please open a GitHub issue.
So I'm just going to jump in as chair here. Is your suggestion to leave it open to specifically not finalize the document until the confidential computing community has another pattern that you want to add to this document? Or are you saying just in general, do not slam the door on people doing their own thing? Because if it's the latter, that's...
The latter for now.
Okay, well, I mean, then, okay, this is already done. Because this document only describes a set of patterns, and it is not intended to be exhaustive. So there's nothing that needs to be done to the document.
A sentence saying under confidential computing, there'll be something else done.
Well, it also doesn't describe it if you're doing it in a PDF file. I mean, there's a lot of things that are out of the scope of this document, and it would be the anti list is never going to be exhaustive. I'm going to say that now.
Okay, fair enough.
Yeah, just on that point, I didn't believe as chair hat off, I didn't believe there's anything in the document that precludes any additional delivery mechanisms or other things to be defined in the future. The purpose of the document is really to capture the current state so that there is a baseline from which we can work in the future. So it's not meant to be, and if you do see anything, Mark, that looks like it is precluding I mean, it is an informational document, but from my reading, there's nothing that does that.
All right, Joe.
Yeah, something that's talking about what might happen in the future or how we might accommodate something in the future. Maybe this is something we can put in the architecture spec. You know, I at least we have a hole that's the right shape to put things in, and confidential computing could, you know, fit in some of those places. So.
Thank you.
Yes, thank you. So chair hat on again, just to remind the group, the purpose of this particular document was to be very specific, very technology specific, very focused on doing, you know, listing a handful of ways to get that initial set of credentials delivered to the workload software process. And it's not trying to define a new way to do that, for one thing. There's nothing in this document that's inventing a protocol or process. And it's also not intending to be exhaustive. So please keep that in mind. Did you have more to?
Nope, that's it.
Okay, cool. So with that in mind, who has read the document? All right. So in order for this to be anything close to final, we need a lot more people to commit to reading the document and providing comments and stuff on it. Dean, thank you for that. Joe, anybody else? I'd like to have. Okay, Yaron. Oh, perfect. I was going to say I like to have at least 3 people because usually 2 out of the 3 forget. Sorry, that was Dean, Joe, Yaron, and Mike. Great. Yeah, sorry, I'm bad with names. Okay, that's fantastic. I am going to encourage all of you to read through the document, put your comments on the list, on the mailing list. If there, I don't think we can kick off a working group last call from here today, but if we get positive feedback from folks that, yeah, this is pretty close to being done, then Peter and I can turn that crank.
Sorry, for the record, we are not yet asking for working group last
Right,
call.
yeah.
We are anticipating that we will be in a position to ask for one by the next meeting. But yeah, for that would be great to have more people read it and open issues and complain and all that.
Yep, absolutely. And do keep in mind, working group last call does not mean that it's done. Often it's a process way to get people to actually pay attention. So thank you to all the volunteers and anybody else. Read through the document, provide comments. What's it missing? What's it overstepping? Anything like that. Remember, this is an informational document. It is not a standard. It's not a standards track document. And it is meant to describe specific current technologies. So keep those in mind when you're reading this, because that is a little bit different than what you might be used to for an IETF document. So we do produce plenty of those, but you know, there is a difference in tone.
Okay, thank you.
Awesome. Thank you. And the queue is empty, so we're gonna move along.
Arndt.
All right, you should get slide control.
Can you hear me?
Yes, we can hear you.
Perfect. Okay. So this is WIMSE Credential Exchange. It's an individual draft, rather new. It hasn't been there since the last IETF. And the idea is to look at credential exchange, or like, that's why it's also called credential exchange, not token exchange, from a bit of a higher altitude and kind of break down the problem into a more abstract way. It doesn't define anything new. It's rather just talking about how one can do exchange, what to look for, and also why exchange should be your last resort. So what I'm describing is what situations require a workload to obtain a different credential. So as if, for example, you're a workload, you have a credential, but you, in any kind of situation where you require something else, your current credential is not fitting enough for various reasons. And then once you kind of come to that conclusion, what mechanisms exist to obtain that credential? And then last but not least, looking a bit into existing patterns, for example, the OAuth token exchange. And also then there's this approach to come up with a new pattern, but it's more like describing the pattern rather than the exact protocol, because the exact protocol will depend a lot on, for example, the credential format and sort of what trust framework you're in. Yeah, so the scope is to kind of describe this meta pattern of credential exchange, but don't get into details about specific format or certain sort of things. Yeah, so in the draft, we talk about the needs for a credential exchange. So workload, once it kind of came to the conclusion that the current credential does not really work, there could be various reasons for that. For example, it requires a change in authority. It's some sort of cross-trust domain sort of situation. But it also may require a change in subject, impersonation, delegation. It could require a change in scope. For example, it currently has some sort of global issue credential, but it needs something very narrow scope because it doesn't trust its peer as much with that global credential. It could be a change in lifetime, could be a change in format, for example, or it could also be the missing provisioning support. So, for example, I've been provisioned with some very basic credential, but I need to kind of step it up a bit and get something else. And my platform is just not able to provide me that. And in most cases, it's just a combination. For example, a change in authority is always a change in subject because the subject is kind of part of an authority. So if I change my authority, my subject by definition cannot stay the same. So in the draft, I kind of try to abstract the exchange or like the way to obtain a credential into three major mechanisms. One of it is the initial provisioning, and that is basically a credential the workload gets born with. So at the life cycle of a workload in the beginning, at startup, the credential gets provisioned to the workload by default. It often happens with environment variables, for example, that the workload kind of gets this credential right there at the start. Then there is the on-demand provisioning, and that is when the workload actually on-demand asks the platform for credential to be provisioned. Spiffy, for example, is one of these situations, or instance metadata endpoints in cloud environments where the workload kind of needs to call a service and gets a credential on demand. And then at the end, there could be like this exchange where a workload already has a credential, either initial provisioned or demand provisioned, and it kind of exchanges it to some issuer with some other credentials. So it uses that credential it has already to authenticate, and it gets back a secondary credential, actually. Like there's also this terms of primary and secondary credentials. The first two kind of would be primary credentials the workload has, and then from the primary credential, it can then obtain via an exchange a secondary credential. Yeah, and now it gets interesting. This is sort of a try to map the needs, why you would need a different credential, and which one you should do. So for example, in a change in subject, you should always prefer to do on-demand provisioning. And if another option would be initial provisioning, but you kind of risk to over-provision or to provision something you don't even use, but you should not use exchange for that. Yeah, other situations are there, and I kind of came to the conclusion, and maybe that's interesting what other people think, that the only reason or the only legit use case for an exchange over initial and on-demand provisioning is actually the change in authority. Because for provisioning, it kind of gives the notion that it's actually the authority of the platform that is kind of provisioning it. And if you need to change an authority, you need to talk to someone else. And then in that case, it's always going to be an exchange and not kind of initial provisioning. Yeah, Mohammed, do you want to ask a question now?
So on the last slide, you had the definition or kind of the description of the exchange. I'm trying to understand that how will the in the last case of exchange, how will the previous credential be revoked? Is there some kind of a revocation mechanism by which the previous credential which was issued is no longer valid? Is there something like that?
As of today, I don't think there's any sort of mentioning of revocation in the draft at all. It's a good question. However, revocation is very specific to the format again. So in order to talk about revocation, you need to have some sort of notion of the format or even the framework where you deploy that framework, that format in, right? So for example, X509 has its CSRs. And there it depends, but for example, even if you have a private CA or you talk about a WebPK environment, if you talk about tokens, then the question is, are you talking about an OAuth environment token where you may have something like a status list that's coming up? So it's difficult to talk about revocation because we don't even know what format is there, if that makes sense. Okay, now the queue is exploding. Can someone lock it, please? I still want to get through my agenda.
Sure. You're on your next.
Does that answer your question?
Okay. Yeah. Do we want to go through the queue now or hold these to the end?
Let's do it now. It's fair because I took one question, so let's take all of them. That's okay.
Okay, I did lock the queue. I'll open it back up once we get going again.
Thank you.
So I'm not sure about the difference between initial provisioning and on-demand provisioning. I think it's also a matter of perspective. So if I'm running on a Kubernetes cluster and the cluster is doing provisioning for me, then from a spiffy point of view, this is on demand. But from a workload point of view, this is really initial. So I'm not sure if the difference is really material. And also as a kind of follow-on to what Osama asked, I think we should also consider long-lived workloads. And so whether you can renew or freshen up your credentials as you go. So this is somewhat related to revocation as well. But that's another use case that would be interesting and would call for APIs, well, as opposed to environment variables.
Yeah, so the idea here, or the main differentiator is the kind of this sort of provisioning by default, even though you don't pick it up. For example, Kubernetes service account tokens, right? If you mount them into every pod, and even though just 10% of the pods are actually picking up, you have 90% of your credentials that you issue are not used. And if I'm not mistaken, actually in the one of the top 10 of workload identity and so on, it actually is one of the, it shows up there that actually credentials are issued but not picked up, and they are definitely a risk, right? You maybe don't monitor them, etc. So this is kind of where I differentiate between those two and kind of say like, hey, do not do initial provisioning, rather do on-demand provisioning, because you only actually provision and issue the thing when you actually need it.
Okay, thank you.
Just a general comment on chair hat off. In terms of revocation, the general practice with these workload identities are that they're very short-lived. The workloads themselves are often very short-lived, so you kind of get to avoid dealing with the revocation problem in that case. And when you get into sort of large-scale revocation infrastructure, having a short-lived token actually just solves a lot of problems, because by the time you have revoked, just the time that it takes to elapse and propagate, etc., is a big deal. So, generally the pattern we see is short-lived credentials, and that gets you out of this out of revocation jail.
Mark, go ahead.
So where does remote attestation fit on this picture? So certainly not the first one, I guess in most cases. I would argue not the second one, because like in Spiffy, you do on demand, you ask the platform for the credential, but you don't really trust the platform. And it's not really the third one, because you don't really authenticate to an issuer, right? You have to go through a kind of a different process. So do you want to handle remote attestation, related
Yeah.
credential issuance, or is this out of scope here?
This is a super new document, so we can do whatever scope at the moment. We can do whatever scope we want to, right? And if you feel like there's a fourth one with remote attestation and it kind of fits into the picture, I'm very happy to add it.
Okay, then we'll handle the 3 issues. We're not going to take up the time now. Thank you.
Okay. And last but not least, I also kind of talk about existing framework-specific exchanges that are out there. For example, OAuth2 with token exchange and assertion framework. And I also try to kind of put them into what sort of needs do they satisfy. So for example, OAuth token exchange is perfect for a change in scope, or a change in, you can also use it for a change in subject, like identifier, but it's not great and you should not use it for a change in authority. On the other hand, the OAuth2 assertion framework is primarily a change in authority. So it kind of tries to bring that terminology that is introduced into the draft and overlays it over existing kind of existing work, kind of also kind of help people to kind of deploy them. So, personally, I think it's not gonna be possible to build this silver bullet exchange API, and I don't think we in any way we should do it, because it would cause more harm than good. Because every token format, every different framework, OAuth, etc., they all come with their own sort of security promises, their all sort of little notions, scopes, and it's going to be impossible to build a silver bullet API without doing something majorly bad or adding security compromises into it. Yeah, so that's also wording I'm kind of added into the document. Let me actually skip this in order to kind of meet the time, but there's also kind of the idea to add a pattern of provisioning where you kind of take the advantages of on-demand provisioning and in the background you exchange, right? So you kind of talk to your platform, but in the background, the platform actually notices that it's something else and would perform the exchange for you. If this is something that fits into your deployments, etc., please reach out. Also have security considerations, for example, that a exchange cannot replace provisioning, right? You always need to authenticate your exchange, so you always need to have something provisioned. And for example, that exchange can never increase trust, because you always have that authentication that is kind of your base layer of trust, and you cannot increase trust by exchanging something. Yeah, and I would be curious if the working group thinks this is something we want to work on. Are there other protocols out there we should highlight? And yeah, what do you think about on the behalf of exchange pattern that I did not describe? Yeah, maybe it would be good to focus on the first questions in order to kind of meet the time here. Thank you.
All right. We'll take a couple of questions and comments right now. We've got a little bit of extra time. So, Mark, go ahead.
What do you mean by increased trust?
As a concrete example, imagine you have a bearer token and you exchange it to a proof of possession token. Generally, a proof of possession token has a kind of higher trust. And the bearer token can easily be eavesdropped and so on, can easily be stolen. So a proof of possession token is kind of a higher trust credential, and you should not just take a bearer token as an input and print out a proof of possession token. So if someone has stolen your bearer token, the person would even be able to get a proof of possession token and then kind of increase trust from there, and then end up with something that is globally trusted because it's like the most secure credential type out there. That should not happen.
That's a great example. I don't see how you can generalize it. Maybe you should just say that. Or do you have other examples of increasing trust that would then make it sort of a class of events that you seek to prevent?
I don't know. I think I make this example into the draft. Maybe there's another one. I don't recall at the moment.
Okay, thanks.
Joe?
Joe Salloway. I do think that this is a useful. I haven't read the draft, so but I do think kind of this discussion is useful, and maybe some of it should be wrapped into an architecture spec or something that the architecture spec references, because this is something that we kind of reference in a couple areas with cross domain and we don't have a lot of specifics around it. It's an area that we need to do more work. So I think this is good.
Cool. Thank you.
So I think it's a good observation that that learning about no silver bullet. I am curious if there is a specific credential pattern or exchange that you've observed that you think would benefit from being standardized.
To be honest, apart from the token exchange and the assertion flow in OAuth, I have not come across much else work that is out there. Maybe if there's other work, maybe in the X509 with PKI space and so on, that would be very helpful. But yeah.
Hannes, you have a comment?
So maybe to not overreach the time here, if this is something you feel interested in, then please reach out to me and we can work together and bring this back up again at some interim or next IETF.
Go ahead, Hannes, and we'll wrap this up.
Yeah, there's a lot of work that can be leveraged here. Like X509 obviously is out there for a long time, and all the PKI related protocols can serve as an inspiration. And in some sense, if you abstract it high enough, Depop is actually nothing else than a CSR in the PKIX world. Think about it.
We're not going to debate this right now. Yeah. Just think about it, Brian. All right.
Okay. Thank you.
Let the notes please record Brian's what? Okay. So thank you, Arndt, for the presentation. If you haven't, please read. There is an ID for this one, right? Yes. Okay. If you haven't, please read the ID, comment on the list. This is token exchange related stuff, and especially cross-domain token exchange is well within the WIMSE charter. So if this is something that we want to do, then please, and this document is a good starting point to kick off some of that. Please review the document, start the conversations, and we'll see if we want to pick that up. Brian? Yes, so it'll be in the meeting minutes. Arndt, could you please send a link to the draft to the WIMSE list also, please?
I think there was already one like a couple of months ago, but I can share it again because now it's fresh and everybody knows
Yeah.
the context. Yeah.
And we'll add it to the meeting notes too. So awesome. Thank you. All right. What's next? All right. Yeah, go ahead. I gotta set it up, but go ahead, get started.
Okay, so I am Musama from TU Dresden, and this is joint work with Mariam and Thomas from Aalto University. And this work has overlaps with TLS working group as well as remote attestation working group, the RATS working group. And we believe there are also some problems which both of the other groups cannot solve, and most likely they can be solved within the WIMSE working group, some identity related problems. And I also want to introduce the confidential computing, which was already mentioned in Joe's talk. So it might be a good overlap also with this working group. And the ask from our side is that are there people who are interested in this work, or is this something for the working group to carry on, or is this something not of interest? So I want to thank my travel sponsor, GenXT, for me being here. And I have organized it as to give you some context about what this problem is and what problems are still open and can be tackled in this working group. From context perspective, you have already heard about the two drafts, which are the workload to workload draft, which talks about TLS, or more specifically mutual TLS. And then the architecture draft talks about attestation. It's unclear how do the both things come together, that how do they combine with each other. And more specifically, it's never mentioned in any document that whether it is, so we have a categorization of all the three solutions, all the three ways in which one can combine attestation with the TLS protocol. And that classification is basically this diagram, which is showing the pre-handshake protocol. From attestation perspective, the most important thing is when the claims were signed. And if you sign it before the TLS protocol has started, time going to the right, then that is the pre-handshake attestation. That is, attestation happened before the TLS protocol had started. So the TLS protocol consisting of key exchange and the authentication part. And if it happens within the TLS protocol authentication part, it is the intra-handshake attestation. And if it happens after the client has finished, so the client finished message, that is the handshake has finished, that is the post-handshake mechanism. So we believe that it is an exhaustive classification, meaning that any combination of any reasonable combination, of course, you can have some combinations which are non-performant, doing the combination of both, which is kind of useless. So any reasonable combination will fall in any of the three categories, and we would very much appreciate if the solutions would precisely clarify which solution is recommended or which solution they are looking for. We have a couple of drafts. The intra-handshake attestation already in the TLS working group, and there is a new draft that we have for the post-handshake attestation using RFC 9261, which is also mentioned on the slide. And with this, I want to give you some context of the TLS, which hopefully this audience already knows, and comparatively with what is remote attestation doing compared to that, and to build some security considerations from that and how the problem arises or what exactly the problem is. So like in the PKIX-based certification, the certification authority, there is a CSR from the server, it issues the certificate, it provides the public key to the client, and then there is a TLS protocol ongoing between the two through the untrusted network to establish the connection. Analogy to that is that now the trust anchor on the remote attestation side is the hardware manufacturer itself, and there is no identifier as you see in the bottom. So that is the evidence contains measurements, that is the hash of the code rather than the identifiers ID mentioned on the slide. And the public long-term key, which was in the TLS, is now replaced by an ephemeral key, which is represented here as pub EK. So the hardware manufacturer at the manufacturing time will provision the key priv AK, the attestation key to the hardware, that is the attester, shown as the RFC 9334 terminology. And I combine the two roles of RFC 9334 represented as verifier and relying party merged as verifying relying party. So the core idea is that now every device in essence has now a certification authority inside it. So if one of the device in the whole world breaks, it means the security of everyone is lost. That's what essentially this diagram is representing, as compared to having trusting a number of CAs. So this is the threat model of confidential computing, which is namely the cloud provider itself is out of the TCB. That is, it is untrusted. And what is trusted is the virtual machine. For instance, if we are talking about the VM-based trusted execution environments, and also the quoting agent, which is generating that evidence, signing and generating that evidence. And then finally, some platform related stuff, which is kind of the hardware, firmware, and the software. And then the open problems that I would like to be addressed are a couple of them. So I will describe them in some detail, which is that the CSP now in control of everything. The step one that you see there is can divert the connections to any machines that they have within the CSP. And for instance, if one of them is broken by some attack, for instance, like foreshadow, some kind of transient execution attack, so that has already been shown in the already been demonstrated to be broken. So even with small TCB like SGX and VM, of course, you have now a much bigger TCB and more likely to be broken. So what happens here is that the quoting agent, which was to generate a right evidence. So now if this key is leaked, the attestation key is leaked, it can now generate any evidence that you want. It can generate an evidence with measurements of the original one, which is shown here as M1, and associate the public key, which is from the second VM, that is the VM2. So with that public key, it generates that evidence and then sends it over back to the VM2, and then VM2 sends in step 4 over to conveys it over to the TLS client, which then verifies it, and in its public or in its trust store, it has already the pub AK2, which means that it will definitely accept that evidence as coming correct. It sees that it has the right measurements, meaning it has M1, the measurement that it wanted to have, the hash of the memory, and that's why it will accept it, and it will just start a connection with the second VM, which was not the intended one. That means it loses the key or the secrets. So the same attack happens in the other side, which is now with the server as the server as acting as the verifying relying party, meaning that the client here in this case is the attester. And this was one of the solutions proposed to me, that how do I actually provision the identity and the long-term key by the editors of the draft, the intra-handshake attestation draft that I mentioned before. And the main idea was that you embed within that container the identifier and the long-term key, and then encrypt that workload such that the decryption key can only be available to the workload once it has done that remote attestation. And I argue that the same problem will still occur because the CSP is now in control of that machine. It can retrieve that key, it can divert it because it is in control of the DNS as well, and it can do the same thing that I just mentioned. With that, these are some of the references. If you want to look further, I want to thank all the people who have contributed to this, and I would like to see some feedback from the working group, what people think about this, and more specifically, this we believe this relates to the token issuance problem, and if there is interest in the working group to tackle this problem.
All right, Arndt, you're in the queue.
Yeah, Anfang Schuster. From how I understand is that in RATS or in a remote attestation, it is a remote, I think you call it attester, that is actually kind of needs to come kind of maybe with a signature over those claims. Is that correct? That it's like it's a lot about that you as a workload or as a piece of software, a piece of hardware, need to get attested from someone remotely.
Right. So that's correct. Think of this like this is running in the cloud. So this in this figure, like the CSV box, which is shown here, is the cloud. So the cloud provider is controlling this, and the TLS client, let's say, is your own machine. And you want to run that VM inside the cloud provider premises. And you want to be sure that it's really your VM rather than the VM which is provided by the cloud provider.
Okay. I think in WIMSE, our environment looks different. And I would say that in WIMSE, we often talk about platform issued credentials, and that we often consider the platform as somewhat trusted.
Right.
And that gives us a lot of capabilities, for example, that we do not need to use attestation via TLS. We can just kind of get it from the platform. That's my kind of thinking when hearing this.
Right, thanks.
All right, we are at time. Thank you.
Thank you.
So before you sit down, though, before you sit down, it's okay. Do you have a draft for this working group to review?
Not yet.
Not
So
yet?
we have
Okay.
the 2 drafts that we mentioned.
Right.
But not yet for this working group.
Okay. I would encourage you, when you have that one that is sort of targeted for the WIMSE specific things, please send it to the list.
Sure.
People read it when you get a chance when that goes in. Thank you very much.
Thank you.
Okay. I need to undo the slides and then do the slides. Next up is Hannes, I think.
Okay. So this is a presentation on behalf of the Confidential Computing Consortium. So Mark is on the call, as you have seen, and he's leading that group. So why am I actually talking about this? Because I'm participating in a group, a couple of others here too, and just wanted to basically highlight some new work in the Confidential Computing Consortium, and specifically this group on this special interest group, as it is called, on trustworthy workload identity, which specifically focuses on the question of how can the work in WIMSE be leveraged for the confidential computing environment. We've had a few discussions already so far on like how does that fit? How does the remote attestation fit in here? What are the differences? And I think that's what we essentially want to find out, like what's the interconnection points. So it's early stages, so like everything work in progress, but I want to spend a few minutes on walking you through some of the definitions and discussions on the requirements. And there's more in the appendix of the slide deck, the current snapshot of a requirements document, and also pointers to this sort of work in progress documents. So hopefully that will then, in the end, when it's sort of more mature, it will give a good picture on how current technology that doesn't use confidential computing in workload environments then fit with the concepts of confidential computing. Okay, next slide. Oh, I have to click.
I was going to say,
yeah, okay.
that's a you problem.
Cool. Okay. So, so why are we talking about this? So, as you all know, confidential computing has some extra, or not all know. Brian is shaking his head. Some of you know that there's with confidential computing, there's an attempt to beef up the security of workloads. In essence, what it seems, what is happening in the industry is that different technologies, whether it's from ARM, Intel, IBM, and AMD, and so on, that they focus on an abstraction that is based on virtual machines, but then containers run inside that virtual machine. So that's these confidential containers. And there are sort of 3 different types of properties that are supposed to be added. Namely, one is on the better isolation, software isolation. So the depending on which threat model you believe in, whether it's the confidential computing threat model or maybe the threat model that some companies entertain that is a little bit weaker, like Amazon's threat model for confidential computing. The idea is that you could run a workload in a service provider in a cloud environment and run a workload there, and the workload is encrypted, and the provider of that infrastructure does not see what computations you are doing. So that's a pretty significant or strong threat model, and we'll see whether that technology lives up to those promises. So it's still early days in some sense, but there's a lot of work on both on the hardware side as well as on the software side being done right now. So the first point is about this extra isolation. There's also the need for a strong binding between the workload credential that is provisioned to the workload and also the instance of the workload. And finally, also the linkage or lineage, as it's called here, a term that I'm not familiar with. Yeah, lineage. I call it the linkage between the credential and the actual issuance or the issuer of that credential, because there needs to be some relationship between the two. Usama.
So the first point I think is quite misleading. You said that you want to improve this. I am not aware of any technology in confidential computing for which you don't need to trust the hardware. That's an absolute necessity requirement, whether you talk about the confidential computing model, confidential computing consortium model, or whether you talk about AWS. So
it's probably just unfortunate wording. So what it means is extending. So like if we look at the isolation technology that is used in WIMSE without confidential computing, in comparison to confidential computing, so there's another layer of isolation that is being added here in confidential computing. I think that's what this sentence is trying to say.
Right. I agree from the operating system point of view. That's fine. So you add additional layer of security with removing some of the software layers out of the TCB. But the whole point of confidential computing is that you are changing, as I presented, from the CA to the hardware. Hardware is where the root of trust is. That's your trust anchor. That's not possible to remove it. So how can you?
It says hardware owner. Go to the mic.
Please use the microphone and join the queue. Just use the mic this time, but please in the future join the queue.
Yeah, it was just to,
just introduce yourself, please.
Manu Fontaine. The sentence says against the hardware owner and administrators. So it's not saying the hardware, it's the hardware owner and the administrators.
So maybe the wording could be improved, but that's why I was adding that context. So more isolation. So what is this SIG this special interest group trying to do? In WIMSE, we mostly, as we have seen so far, focused on existing technologies, container-based technologies, and but there's in the confidential computing, there's obviously, as the name indicates already, it's an industry consortium that focuses specifically or collects all the different players, stakeholders working on both the hardware and the software for confidential computing. So it's a good set of interested parties to discuss the details of their technologies, and the idea is to convey that knowledge, to collect that, and then convey that also to other groups like the group here, and of course to be compatible with existing efforts as much as possible. We've previously seen with Arndt's presentation, there are different patterns, and some of those, for example, this whole idea that you create the credentials outside the workload and then push it into the workload is obviously not really compatible with the idea of confidential computing when you don't trust the platform that is running outside. So that, remain compatible is a desirable goal, but it's there are some things which you can't really do. Monty.
Yeah, Monty Wiseman, Beyond Identity. So is this entirely, I guess I'm getting mixed messages here. Is this entirely focused on a technology that can in fact isolate the workload from the hypervisor or the management software versus the hardware? Or would this technology extend to, for example, a traditional hypervisor like KVM, and you can attest to the hypervisor and therefore decide that it's trustworthy based on, for example, the platform's TPM? Is it more open, or is it highly closed to confidential?
So we are specifically talking about technologies like TDX, Intel TDX here, or ARM CCA. Those are confidential computing technologies which have more than just like a hypervisor.
Okay,
like
so
if you look
so
at
it's
the
it's very narrowly scoped.
Well, it's a bigger industry effort, so it's depending on what you call narrow, but
Yeah,
it's
of course, of
I would
course.
say it's a pretty big scope. Like there are many different hardware vendors developing this technology right now. So
Right,
it's,
but
in that
this
sense,
would
broad,
exclude
but
this would exclude technologies that don't rely on or don't have the ability to do that. This would exclude that.
that's correct, because they can't just provide those properties.
I
The
I
properties of
disagree with that, but okay.
Interesting. Okay. We can discuss that.
Yeah, we'll discuss
I'm
that.
curious how you want to get this working. Usama.
I think there is no need to reduce the scope. So from credential issuance perspective, so what I believe is like you can still have process-based isolation, or like in Intel SGX, you can also have the VM-based, as you mentioned. You can also have the containers. I believe from this work's perspective, we do not need to limit the scope only to a specific one, like VM-based or process-based. I don't see any reason why you would limit the scope to a specific one. In follow-up to what Monty was saying.
Interesting.
Do you see any, or let me rephrase the question. So do you see any limitation of any one of the three, like process-based, VM-based, or a container-based, that you would like to limit for this a specific reason, or don't you think that it's applicable to all three?
So my sense
From
is
WIMSE.
where the industry is moving. They are moving to these virtual machine-based sort of systems. But Mark can probably answer that better. That's my impression, and they are not focusing on the other technologies. But maybe you can still define solutions for older technologies.
I want to point out we are already at time, and you're on slide 3 of 10. Do you intend to finish this presentation, or
Probably not. I'll skip through it and then let Mark say something at the end. You have the slide deck. This is probably the most interesting one. Ongoing work on requirements. So if anyone is interested in this group, to also join that conversation. We have conference calls. Mark is entertaining these calls. He's leading the group. The group is Confidential Computing Consortium. Is a very open group, so you can join without being a member. I'm there. I'm not a member of that organization. I'm not paying anything or whatsoever. So I think the invitation to those who are interested to participate in that conversation is open to all of you.
As chair, I do feel the need to point out that this is non-IETF work. It is not covered by the IETF Notewell or any of the IPR protections granted thereunder. It's its own thing. Figure out their rules. We are out of time. Mark, if you have something that you want to say to close it out.
You're muted.
Please unmute. Yeah, so just pay attention. You can download the deck. The most important bits are the definitions we're coming up with for what constitutes a trustworthy workload identity. And I think that's probably the bits that we would like to inform WIMSE of. And I want to stress that we are after compatibility with your efforts, and maybe some minor tweaks to your architecture. Like I heard it said a minute ago, that the platform is at least somewhat trusted, and these are the kinds of things that we'll probably take issue with. Let's not over constrain the problem.
Okay, Thank you all, and catch me in the hallway.
All right, thank you. Okay.
Are you able to hear me?
Yes.
Okay, thank you.
Do you want control of the slides?
No, that's okay. Yeah.
Oh, okay. Well, you have them.
Yeah, okay, perfect. Thank you. Thank you for the opportunity. I'm Ramki Krishnan from Intel, and on behalf of my co-authors, we're going to talk about WIMSE impact on data residency requirements for handling sensitive data. So just a quick introduction. If you look at sectors like financial services, healthcare, and government, they have sensitive data. And basically, they have data residency requirements, which means geolocation affinity and host affinity as part of the requirements to protect such data, right? What is really geolocation affinity? It really means the workload is cryptographically bound to a geographic region or area, right? For example, workload must be in, Spain, right? As an example. Host affinity, workload is cryptographically bound to a specific execution environment. It means it translates to a specific host or a set of trusted hosts. In fact, we have a nice keynote and white paper on this topic at Trusted Computing Group. Please go through it when I get a chance. The links and really to summarize, what we get to is like really be able to explain by meeting data residency requirements, what are the security benefits. Typically, people think about this as compliance benefit, but it's much more than that. We get into several attacks, different types of attacks, and and then how we can address them. Please go through these. Next, let's get into what does this mean for WIMSE? What are the aspects we need to consider from a WIMSE perspective? Critical workloads when it comes to AI inferencing or anything else which process sensitive data need to run in a safe geolocation. Like, for example, a geographic region, like a well-known city, maybe Berlin in Germany, right, as an example, or Santa Clara, US, California, right? So basically, this is geolocation affinity and in trusted host affinity. So with respect to WIMSE, this means that the workload identity, right, needs to be cryptographically bound to the platform identity and the domain identity. And to just tie these together, what does domain identity mean? There are several examples: geolocation area, or it could be RFC 7482 domain patterns, right? And when it comes to platform identity, there are several examples. Fundamentally, the device ID. This could be a TPM endorsement, right? Or IEEE 802.1 AR. Or again, we had so much about confidential computing. Actually, it nicely brings it together. The confidential computing hardware TE ID. In fact, the CPU itself has a unique ID. Basically, it's from AMD, SCV, SNP, or ARM CC, or Intel SGX, TDX. So basically, the crux of it we see is the workload identity needs to be bound to the platform identity and domain identity. Moving on. So what does all this mean? Basically, the identity service providers manage the different types of identities: workload, domain, and device identity. So typically, the workload identity is managed by the workload orchestrator during runtime and service provider during build time, right? And then the domain identity is managed by, for example, domain name register, right? Or also known as DNR. And this is all part of the lifecycle management. And then the device identity managed by device manager during runtime or device vendor during manufacturing time. So far from what we have seen, there is no standards-based identity provider who cryptographically binds these identities as one aggregate identity, right? And again, we're not saying this is useful for all the use cases. Basically, specifically useful for use cases with sensitive data. And this is sort of where I think confidential computing also comes into play. So for example, just a little bit of detail on confidential computing, when you get a hardware code, it has got the workload identity, or you can call it the code hash, right? And also the TE-ID, the device ID. And basically, the opportunity we see for WIMSE is to cryptographically bind these three identities as one aggregated identity. That ends our presentation. Open to questions.
All right, Osama.
So if you go back to last slide, please.
Yep.
Oh yeah, maybe sorry. One before.
Yeah, I have control.
This one, yes. So can you clarify precisely what exactly do you mean by platform identity? Because I have worked with Intel SGX, TDX, ARM CCA, and at least for three, Intel SGX manual specifically specifies this is not a true hardware identity. So can you be precise? Can you tell me precisely which exact field in the Intel SGX code are you referring to as the platform identity?
That would be the hardware. I think it's hardware ID or TE ID. I forget the. Maybe if NED is
there is no field like hardware ID or TE ID in SGX. So can you be more specific on what exactly is the field in the code that you are talking about?
I can get back to you on that. I believe there is. I think it's called QUID. Now that I think it's quoting enclave ID. There is one field called quoting enclave ID.
Quoting enclave ID is not a platform identity. That's written in the SGX manual. That's incorrect.
Okay, that I agree. That's I can remember, but let me dig up and get back to you.
Sure, thanks.
Okay, I think we are at time. Ramki, thank you so much. And in terms of follow-ons, I don't know if there's a specific proposal that you would like to make, or if you're planning to submit a draft to the working group to outline some of your ideas here.
Thank you so much for the input. Like if there is interest in the working group, we'd definitely love to submit a draft, actually. Thank you, Peter, for that suggestion.
One of the best ways to find out if there's interest is to submit a draft and see if people actually read it. So do the draft first. Don't wait for people in the people to say that they're interested before you put a draft together. The language that the IETF speaks is internet drafts. And so the best way to get your ideas discussed is to put it into a draft, even if it's full of holes, because that's the best way to get a conversation started over a concrete document. So if you have part of this that you would like to put forward, I encourage you to do so and send a link to the list when that is published. Thank you.
Thank you so much.
All right, and with that, we've got 12 whole minutes of any other business. So at this point, if there are any questions or follow-on conversations from previous presentations that you heard today, any follow-ups people need, any sort of next steps or anything like that, or if there's any other bit of work that you want to draw attention to, either this week in Bangkok or in the world in general, that the WIMSE working group should be paying attention to, and or you want people to pay attention to, now is the time. So the mic line is open. Mark.
So yeah, I'm a little miffed we didn't get to the discussion around trustworthy workload identity. Perhaps we can take 2 minutes and actually go through those slides right now. If we have a little bit of extra time, I would also like to know if you guys want to see this as an internet draft at some point.
I will repeat the advice that I just gave, and that's that don't ask for permission to create an internet draft. Create an internet draft to get interest. Do you folks in the room want to go back to those slides? Other than Hannes? Yeah, okay. I will pull the slides up then.
Yeah, let me just walk over through them real quick. So yeah, go to the supporting definition slide.
Oh, I have control. Oh, wow. Okay, cool. All right. So these are the supporting definitions. So we take WIMSE definition of workload and we basically say, look, it's the same thing as what WIMSE defines as that, but constrained to just the parts of the workload that are subject to remote attestation. And obviously, with confidential computing, if you can't attest it, then you don't know what it is. Workload identity, we'll take feedback on. We just for now just call it a stable construct, such that we can have relying parties have authorization policies for these workloads that stay very stable. That's kind of a management requirement. Where workload credential can be very short-lived, and it's just a way of communicating the workload identity to the relying party. So I think that should be uncontroversial. Workload lineage is something we're introducing because we effectively need a way to look at a credential and be able to decide, do we actually want to trust it? So in our documentation, we say, well, Bob can keep secrets and Bob can be trusted to, execute, certain code, much like, Hitler could have been trusted to hurt people. That doesn't mean that Bob is trustworthy. We need some additional step, and this is what lineage is. Probably subject for more detailed discussion, but we can have that. And these are this is the last slide I want to go through here. We're basically saying a workload identity is trustworthy if and only if the following three properties hold. The first one is an isolation property. So you have a workload that's confidentially integrity isolated from all sorts of things, the hosting environment, the hypervisor, peer workloads. The second one is a strong binding requirement. So it cannot be bearer token. If it's a trustworthy identity, you actually need to know that it came from the workload. And the last one is when you look at the workload credential, you can trace it back to the workload's lineage. And that could be an issuance policy OID or a serial number, but anything that we can look at and then make a real-time or an auditing decision after the fact on was this a good decision to trust this credential. Anyway, that's really it. That's our current state. We welcome all participation.
All right, we've got a few folks in the queue.
Right. So if you go back on the last slide, please, although I have questions also on this as well, but let's start with that.
Last slide, as in this one?
So this one, yes. So you are talking about workload identity is a stable construct. So can you clarify whether you mean this is referring to the, so in confidential computing, we have two types of measurements, like initial measurements and extended measurements or runtime measurements, right? In CCA, that would refer to RIM, and the second one will refer to REM. So which exactly are you referring to? Is it the first or the second or both?
I don't know if I want to get into this depth. 6 a.m.
Mark, please hold your mic closer to your mouth. You're cutting out a lot. Thank you.
Sorry. Yeah, 6 a.m. Pacific is when we discuss these in our working group. I don't think we have the time to go this deeply. But by analogy, my identity will not change in the next 10 years. My passport, which is my credential, will be reissued during that time.
Yeah,
so
but at this, sorry, Mark, so you are talking about workload identity and not your identity, right? So the initial measurement never changes, but the runtime measurement actually changes a lot. There are some workloads which can change at the runtime. So how you can say that I object to this definition saying that workload identity is a stable construct? It's not, because the runtime measurements of the workload can actually change. That's why Intel TDX has the runtime measurements, and CCA, ARM CCA has the runtime measurements. They are there for a purpose, right? So you are defining the term wrong.
Identities, to be manageable and practical, workload identities need to be defined from the standpoint of the relying party. So if the enterprise decides to upgrade the payroll application from version 4 to version 5, from the point of the relying party, it's still the payroll application. So again, we'll have to go in that direction in order to have something that's, that we can manage and deploy.
So then you mean that the identity is referring to the workload identity, in your case, is referring to the initial measurements, and you are ignoring all the runtime measurements. Is this correct?
I repeat my answer, which is it is what the identity is perceived as by the relying party.
Yes, but the relying party gets both measurement. That's my point, right? So my point
the
is
relying party doesn't get both measurements. The relying party gets the credential.
So imagine that you have the verifier and the relying party combined together. So how would you then deconstruct
You don't
this
combine the verifier and the relying party together.
Okay, folks.
That's-
Thank you.
That's why I don't think this is
We're
the
running
right
out of
format for this.
we're running out of
Right
time.
forum.
Maybe take it offline or take
Yes.
it to the list if you want to continue there. Thank you.
And it sounds like there is a venue for discussion of this work, which I will remind folks is not WIMSE.
Yes.
Yaron. Oh, yeah. As soon as you said it, I was like, go ahead.
Yaron Scheffer. So actually, to follow up on Justin's comment just now, this is not WIMSE work. I think eventually it will need to become WIMSE work. There's obvious interest in WIMSE in attestation. Probably not yet, but eventually. And to that point, the Confidential Computing Consortium, CCC, has its own ideas, ideology on what counts as attestation and specifically what the root of trust should be. And that needs to be a hardware vendor that does not address all the needs across the industry. And as a result, I think we, WIMSE, should have our own opinion, eventually at least, our own opinion on what's attestation, and we should not allow CCC or TWI to come up with our opinion for us. So it's a starting point, but eventually it'll be us deciding what's WIMSE, what is attestation within the WIMSE context.
Arndt. Thanks, Sharon.
Yeah, +1 on what Iran said. What I'm curious of is maybe not just to Mark, but also to the attested TLS and general, like also the confidential compute, if there's any existing work out there. Is there anything, for example, in workload environments where this has been added before, like Kubernetes? Is there any existing work out there, or is this just theoretical? Just that kind of for me to kind of put it into perspective where we are at here.
Osama, so just to quickly answer that, so that there are like practical works which are available as well as research works that are available. So I will compose an email with all the links to all the different works that have been done. Particularly also there is ongoing work in the RATS working group and a couple of drafts in the TLS working group about attested TLS that you mentioned. Or
Yeah,
is there something specific that you are looking for?
Yes, in workload environments.
Okay, workload. Okay, right. Thanks.
Yeah, like Kubernetes, for example. Thank you.
All right, thank you all. Cut off the queue just so that we could have a minute to kind of wrap things up here. Thank you everybody for the great conversations today. That concludes the WIMSE working group for IETF 122.
And please remember to go and read the drafts, open issues, and bring discussion to the mailing list or in the GitHub. Thank you and have a great IETF and see you in Madrid.
That's right. See you in Madrid.
Thank you all.
All right, and I think I'm good. Okay. Cool. Hannes, do you need any time to wrap up the notes, or can I copy them over?
I'm just about to. Oh, Darren's merging.
Okay. Yeah.
So we have to.
Okay. Should we set up? I think so.